is a continuation of 9-4 multiplying special cases. We finished up our last video doing Quick Check 3, so we're going to move on to the second half of our lesson, which is the difference of squares. In the first half of the lesson, we learned about squaring binomials, things like a plus b squared or a minus b squared. So now we're learning about the difference of squares. If you were multiplying a plus b times a minus b, you end up with a squared minus b squared, which is why it's called the difference of squares. Difference is subtraction, and the first term and the last term, they are squared. So the product of the sum and difference of the same two terms is the difference of their squares. This is the product of the sum and the difference of the same two terms, and we end up with our answer, which is the difference of squares. So let's see that in action. Example 4, we are finding the difference of squares. So we have to find p to the fourth minus 8 times p to the fourth plus 8. So this is going to be a case of the difference of squares. Since we have the same two terms, p to the 4, 8, and 8, and one we're subtracting, one we're adding. So we're simply going to follow that rule, square the first term minus square the second term. So I have to square my first term. So p to the fourth squared minus my second term squared. Again, I'm just following the rule. Square the first term minus square the second term. That's the difference of squares. So now I'm going to use my rules from Chapter 8. When you raise a power to a power, we need to multiply our exponent. So I have p to the 8 minus 8 squared, which is 64, and there's your answer. Hopefully you could find the same answer if you used FOIL. If you FOILed these out, in fact, let's go ahead and do that. Let's see if we get the same answer. So I'm going to use FOIL. First, outer, inner, last. First times the first, p to the fourth times p to the fourth. When you multiply, you add the exponent, so p to the 8. Outer, p to the fourth times 8, so that's plus 8p to the fourth. Inner, negative 8 times p to the fourth, so negative 8p to the fourth. And last, negative 8 times 6, which is minus 64. Now I need to simplify, combine like terms. I have a positive 8p to the fourth and a negative 8p to the fourth, so those two cancel, and I end up with p to the 8 minus 64, which is the same thing we got when we used our shortcut. So again, the shortcut is just a quicker way to get the same thing you would get if you used FOIL. So let's try some quick checks. Quick check for A, B, and C, they want us to find each product. We're simply going to follow our rule, which says square the first term, b squared, minus the square of the second term, 121. And we are done. Much quicker than FOILing. Let's try B. Again, I'm going to square the first term. So my first term is c squared, and I need to square it, minus the second term squared, a 8 squared. So we can simplify that to be c squared squared, c to the fourth, minus 64. Just like in example 1, 2, and 3, you can skip this step. The more you do this, the better you'll get, and you won't even need that step. Finally, let's try one a little more complicated. Again, I square the first term, so I have 9b cubed squared minus square the second term, w to the fourth squared. Again, the reason we're doing that is because this is the difference of squares. We have the only time you can use this rule, the difference of squares, is when you're multiplying two binomials. They have the same two terms where you're adding one and you're subtracting the other. That's the only time that this shortcut or this rule works, is when you're multiplying two binomials that have the same two terms where you're adding in one and you're subtracting in the other, and you end up with the result of the first term squared minus the second term squared. So let's simplify this. Remember from Chapter 8 that everything inside the parentheses has to be squared. So 9 squared is 81. B cubed squared, we're raising a power to a power, is v to the 3 times 2 is 6, minus w to the fourth squared, again raising a power to a power, so we multiply the exponents, w to the 8. All right, let's try that with some numbers. Again, we said maybe a practical application for this would be if you were trying to multiply some rather large numbers. So let's try 43 times 37. We want to change this into a difference of squares problem. So we want it to look something like this. We want two binomials that have the same first term and the same second term where you're adding one and you're subtracting the other. So how could we do that with 43 and 37? Well, I could change 43 to 40 plus 3, and I could change 37 to 40 minus 3. Now we end up with two binomials that have the same first term, the same second term, one where you're adding and one where you're subtracting, so we can use our rule for the difference of squares. Our rule for the difference of squares is square the first term minus square the second term. And that equals 40 squared, 4 times 4 is 16, 2 zeros, minus 3 squared, which is 9. 1600 minus 9 is 1591. All right, let's try some quick checks using that same method. So again, we're taking the two numbers that we're trying to multiply together, and we need to change them into these two binomials that have the same terms, where you're adding in one and subtracting in the other. So let's try it with these numbers here. 18 times 22. Well, I notice they're both really close to 20. I could rewrite 18 as 20 minus 2, and I could rewrite 22 as 20 plus 2. Now we end up with a case where we can use our rule for the difference of squares. So we square the first term, 20 squared, minus square the second term, 2 squared. 20 squared is 2 times 2 is 4, add your 2 zeros, minus 4. 400 minus 4 is 396. All right, let's try another one, 19 times 21. I notice these are both really close to 20. I can rewrite these as 20 minus 1, 19, and 20 plus 1, which is 21. And again, we use our rule for the difference of squares, and the only time you can use it is when you have the same two terms, 1 plus, 1 minus. So first term squared, 20 squared, minus the second term squared, which is, I'm just messing up this one bad, minus 1 squared. Okay, 20 squared, 2 times 2 is 4, add your 2 zeros, minus 1, so we end up with 399. Let's try some with some higher numbers. 59 times 61. These are both really close to 60, so I can rewrite them as 60 minus 1 times 60 plus 1, and use our rule for the difference of squares. Square the first term, minus square the second term. 60 squared, 6 times 6 is 36, 0, 0, minus 1, so I end up with 3,599. All right, last one, 87 times 93. So this one's a little more difficult than the ones we've been doing, since we're not just simply adding one or subtracting one. But I can tell that they're hovering around 90, so 87 would be 90 minus 3, and 93 would be 90 plus 3, which is great. Now I've ended up with two binomials with the same two terms, one subtraction, one addition, so I can use my difference of squares rule. 90 times 90, 90 squared, minus 3 squared. 9 times 9 is 81, 0, 0, minus 3 squared, which is 9, and I end up with 8,091. Okay, just as a little review, we've learned two rules now. Let's go back to the beginning. We've learned two rules. Our first rule was the square of a binomial. That's when you have a binomial squared, like a plus b squared or a minus b squared. In that case, you end up with the first term squared plus 2 times your two terms plus the second term squared. When you have a minus b squared, it's still first term squared. The only difference is you're subtracting 2 times your two terms plus b squared. And we saw that in example 1, where we did y squared plus 2 times y times 11 plus our second term squared, 121. We simplified. And then we learned our second rule, which is the difference of squares, and that's where you have two binomials, a plus b times a minus b, two binomials with the same two terms, where you add one and subtract the other, and you will always end up with the first term squared minus the second term squared. And that's what we just finished doing. We saw here, or actually let's look at a simpler one, b squared minus 121, or here c squared squared, c to the fourth, minus 8 squared, 64, and those are our two shortcuts for today.